Welcome to my maths class. In this class, we'll solve sums from NCERT textbook, class 9, chapter 3, the world of numbers, exercise set 3.1. It's on page number 43, question 1, 2, 3 and 4. So we'll see the question 1. Question 1 says, a merchant is a merchant in the port of Lothal is exchanging bags of spices for copper ingots. He receives 15 ingots for every 2 bags of spices. If he brings 12 bags of spices to the market, how many copper ingots will he leave with? So he is getting 15 ingots for every 2 bags. Suppose he brings 12 bags of spices, how many ingots will he receive altogether? That they are asking. So we'll solve it. Exercise 3.1. Page number 43. So we'll solve the first question. So for 2 bags he is receiving 15 ingots. So for 2 bags he is getting 15 copper ingots. Suppose then for 1 bag, how many you'll get? For 1 bag, he will get 15 by 2 ingots. So he has bought how many bags? 12 bags. So for 12 bags, he will receive 15 by 2 into 12, because 15 by 2 is for 1 bag. So for 12 bag, he will receive 2 6 are 12. So 15 into 6 will get 90. So he will receive 90 ingots. Therefore, the merchant will be left with 90 copper ingots. This is the first question is solved there. I will go to the question number 2. Question 2 says, look at the sequence of numbers on one column of the Ishango bone, that is 11, 13, 17, 19. What do these numbers have in common? List the next 3 numbers that fit this pattern. So on the bone they have marked these numbers 11, 13, 17, 19. You can see that bone also here. See, they are marked 11, 13, 17, 19. They are asking what do these numbers have in common? List the next three numbers that fit this pattern. So we will question 2. We'll answer the question 2. You can see here the numbers 11, 13, 17, 19. They are the numbers. We have to find out what do these numbers have in common. You can see all these numbers have only two factors. All these numbers have only two factors. Only two factors. That is 1 and the number itself. 1 and the number itself. You can see here no number can divide 11 except 1 and 11. No number can divide 13 except 1 and 13. So all these numbers have got only two factors. They are called prime numbers. Prime numbers. They are asking to write next three numbers in this series. The next three numbers are are 23, 29 and 31. They are the next three prime numbers that come after these. So question 2 is answered there. We'll go to question 3. Question 3 says, we know that natural numbers are closed under addition. It is, the sum of any two natural numbers is always a natural number. We know that the natural numbers are closed under addition. The sum of any two natural numbers will always be a natural number. Are they closed under subtraction? Are they closed under subtraction? We have to find out whether the natural numbers are closed under subtraction. That means we should find out whether when we subtract two natural numbers, we get a natural number or not. So provide a couple of examples to justify your answer. So we'll see here. Question 3. the natural numbers are not closed under subtraction, are not closed under subtraction, because when we subtract a bigger number from a smaller number, we get a negative number. Negative number. The negative numbers are not natural numbers. The negative numbers are not natural numbers. For example, you can see here, suppose I subtract 5 from 10, I get a natural number, no problem. But when I subtract a bigger number from a smaller number, suppose 5 minus 8, I get minus 3. It is not a natural number. Not a natural number. So the natural numbers are not closed under subtraction. So third question is solved there. We'll go to the fourth question. The fourth question says, ancient Indians used the joints of their fingers to count, a practice still seen today. Each finger has 3 joints and the thumb is used to count them. How many can you count on one hand? How does this relate to the ancient base 12 counting system? So here in the olden days, the people were counting by using the joints of their fingers. Each finger has 3 joints and the thumb is used to count them. They're asking, how many can you count on one hand? How does this relate to the ancient base 12 counting system? So question 4. We can count up to 12 on one hand. So the ancient people use this method use this method to count in groups of 12. Groups of 12. This led to the development of this led to the development of base 12 base 12 counting system. So the fourth question is answered here. Please like, share, and subscribe. Thank you.